Element 33 on the periodic table is arsenic. This is Norris Teaches Science. With me, Mr. Norris. This is another Physical Science Edition video. Today we're going to discuss gravity and weight. To the end of the goal, you should be able to say, I can explain the relationship between gravity of a body and an object's weight. You can tell I sometimes don't read my stuff before I do the videos and I'm already in them, so I just start. So like every day, we start with a definition. What is gravity? Gravity is a force that acts on masses and it acts downward. It's a downward force. But remember there's an opposite force to it, and that's air resistance. So that goes up. Gravity goes down. And we do know that the acceleration due to gravity on Earth is 9.8 meters per second squared. That's how fast things fall, especially when there's no air. Now, when we talk about gravity, gravity does factor into a couple ways of motion of objects. One is something called projectile motion. This is motion of falling objects thrown forward. All right, and when this happens, say you throw a baseball, it's going to curve down to the earth in a curving motion. Even if you don't realize it is, it's going to curve down to the surface of Earth. And that's because there's two forces acting on it. You have gravity that's acting down, and you have a forward velocity pulling it forward, causing it to arch. All right, and so causes this curved path. Now, gravity and air resistance I kind of clued in, but there is a relationship. They're opposite forces. Gravity goes down, air resistance acts up, and it's trying to follow Newton's third law of motion. And we can see this if we look at a feather versus a rock in two different locations. One on Earth. You have a feather and you have a rock. You're at the top of the Empire State Building. You drop both of them, and the feather's going to float down to the ground, and the rock's going to fall at 9.8 meters per second squared. Why? Why are they falling at different rates? One, air resistance. Air resistance is going to catch the feather and make it float down, while the rock has less surface areas and is not going to be factored into air resistance that much. Now we could take this feather and we could take this rock, and we can go to the moon, or we can go to a vacuum, which means that there's no air. We're going to a place that has no atmosphere, no air. And if you are at a height and you drop the feather and rock at the same time, they both are going to fall at the same rate because there's no air. And if there's no air, there can be no air resistance. Now, gravity factors into a calculation we have to do called weight, which is technically the force of gravity acting on an object. So algebraically, weight equals mass times gravity, or Fg, force of gravity, equals mass times gravity, m times g. So F of g, which means weight, will have the unit of newtons. M will have will be mass, and it will be kilograms. And g will be gravity, and for all instances, it's going to be 9.8 meters per second squared unless otherwise given. Now in the triangle, remember it says m times g, so m and g will be at the bottom because they have to be next to each other to multiply, Fg at the top. If you don't know the triangle, numbers on top of each other you divide, numbers next to each other you multiply. So let's look at this weight problem number 1. It says a 20 kilogram dude is on Earth. What is his weight? So we're trying to find weight. And so that means F of G will stay in the triangle. We know our mass is 20 kilograms. And it says we're on Earth. And we know that Earth's gravity is 9.8. Now that we know that, we can do our math. Since the numbers are next to each other, we're going to multiply them. And we're going to get 196 newtons. All right, let's do another problem. It says a rock on Earth has a weight of 1,000 newtons. what is the rock's mass? So what are we trying to find in this problem? We're trying to find mass. And we're using the weight formula. So we're going to leave the m in the formula. So at the top goes our weight. Our weight is 1,000 newtons. At the bottom is gravity. It all depends on what planet you're on. This says we're on Earth, so we know Earth's gravity is 9.8. Now we look at the numbers. Are they next to each other or on top of each other? They're on top of each other, so we're going to divide. And when you enter this in the calculator, you're going to do 1,000 divided by 9.8. When you do that, you should get 102.04. And the unit for mass is kilograms. And this is a little bit about weight, how it factors into stuff with friction and forces. I hope you learned something today. I'm Mr. Norris. I'm out for this video. See you at the next one.